We're talking about geometric proofs, and we're talking about segment and angle relationships. And here's a couple examples. So given Mn is equal to Pn, so Mn, so if it says it's equal, so I'm going to say Mn, I'm going to put 3 here, is equal to Pn, and then it also says Ln is equal to NO. And I guess I should finish this. So Mn is equal to Pn. So here's Pn. I'm going to put 3 marks here because that's Mn is equal to Pn. And then Ln is equal to NO. So Ln is, we'll put 4 there. Ln is equal to NO. So then we have to have 4 here. And the reason that we can say that is given. Next piece of information. What are we trying to prove? We are trying to prove that ML is equal to PO. So we'll say ML is equal to PO. So step 1 done, step 2 done, step 3, the drawing is done, and now we got to do step 4 and 5. We got to write our statements and reasons. So we're going to try to get to ML is equal to PO. So what do we know about ML? Well, ML is right here, and we can do segment addition there. So we can say Mn plus NL and that is going to be equal to ML. So that's one of our segment additions. The other segment that we're talking about is PO. So we can talk about PO there, and then we can say PN right there plus NO. Then we're going to say that's equal to plus NO is equal to PO. And the reason that we can do both of those is segment addition postulate. And segment addition postulate again. Okay, the next thing that we can do is we can kind of see what we can substitute in. So we can see that we have 2 different equations, but here we have Pn, and we can see that, or here we have Mn, and we see that Pn and Mn are equal, and Ln and NO are equal. So we can rewrite this equation, and that's what we're going to do. So I'm going to substitute a bunch of values in for this equation here. So what's a different value for Mn? Well, we knew that Mn is equal to Pn, so we can substitute Pn in there. So now we can change that to Pn. We're still going to add, and that Mn is equal to Ln, but how can we get rid of Ln? And we say Ln is equal to NO. So we can take that Ln out and we can substitute in NO. And that is still going to be equal to ML. Now we can see that this is the exact same equation. Pn plus NO equals, the only thing that changes are those 2 values on the outside. And the way that we were able to get that is by that substitution up there. So that's going to be the substitution property of equality. The next thing, once they're both equal to the same thing, then they can be equal to each other. And there's two different ways you can do that. You can say PO is equal to this expression and ML is equal to this expression. So you could do transitive because now they have to be equal to each other, or you could do substitution. Either one works fine there. But regardless, what we can say is we can say now that PO is equal to ML, and we can either say the substitution property of equality. So I'll write that substitution. Or also would be acceptable if you said the transitive property of equality. And now if we go from this step here to the last one, PO and ML, they just switch sides. And so in that case, we would call this the symmetric property of equality. And then we get our proof all done. And then we finish it up by saying QED.